smart grid is such a wide area. You have everything from smart metering and down to substation automation. The whole back office system of the utility of the future will be migrating from what was essentially a 1950s technology into the future, where we utilize modern communications infrastructure as well as advanced technologies in managing our energy in the buildings. And so by providing that initial technology into Pecan Street project, we have the opportunity to learn and to grow and find ways to innovate, as well as bringing those technologies into the built environment. And that's a lot of what I want to talk to you about today. And to follow Brewster's theme, this is truly disruptive technology, disruptive innovation that's being applied to a problem we're facing here in the country. The goal of this seminar is to educate our customers, basically changes related to the building industry, how that affects you. So we're going to not have a commercial. We're going to display our name at the first slide and the last slide, and basically try and do a job of education. I want to start with a show of hands. How many here feel like they have a good understanding of what an energy management system is, what it's comprised of? Show of hands. Okay, there's a few. Basically, what we found is the first step in managing energy is to understand how it's used. And so that's where we start in Pecan Street and in our buildings, in a detailed analysis of what energy is consumed today, how it's being consumed, when it's being consumed. That's why it's so important to have a deep understanding of that data. However, we draw in so much data. As you can imagine, if we're taking in 15-second intervals times 8 circuits in a house, or 6 circuits in a house plus the solar, and times 100, 200, many homes, we're drowning in data. Okay, and so what we really need is the information from that data. Part of the Pecan Street project's goal is to take the data, help with the University of Texas's help on supercomputers and brilliant minds in doing the deep dive analysis of how that energy is being used and how we can apply those patterns to the next phases of controlling energy consumption and being able to reduce energy when we need to reduce it, being able to be more efficient with our energy. It does need to be easy. It needs to be effective. I can't say I know what the killer app is, but I can tell you it probably looks a little bit like an application that runs on your pad or your phone and gives you the capability to easily manage and control, view, have visibility into what's really happening in your energy consumption and what changes you're making and what does it mean for you. Automation, so that you don't have to control every bit and byte. You've got the systems doing a lot of the work. Who could tell me where 50 to 70% of the energy that's being consumed in this country is being consumed? In the commercial building space. That's correct. The commercial buildings in this country consume 50 to 70% of all the energy, and 90% of the commercial building market is comprised of low-rise buildings, under 20 floors, rooftop units. The primary energy consuming device in these buildings is heating and air conditioning. Today, less than 5% of these buildings have any form of energy management whatsoever. They're basically, energy management is comprised of people running around trying to adjust thermostats, trying to turn off lights, and you can imagine the problem. You probably have faced this at home. You're trying to turn off lights after your kids, or you're trying to manage your energy on 1 or 2, maybe 3 thermostats. Imagine what it looks like for a building manager with hundreds of thermostats, hundreds of buildings potentially if they have a chain of buildings. And so what we need to provide is a way for building owners, building managers, tenants to easily control and manage their energy consumption and reduce their costs. So the question is, why would we upgrade buildings? Why do we create green buildings? The the simple answer is, on average, there are 2,000 existing buildings for every new one that gets built. And so there's a large built environment, and so the opportunity to come in and provide energy efficiency in those buildings is immense. You can also see that most of these buildings are on the small end of the scale in terms of size. And so about 90% of them are less than 25,000 square feet. And they, that's really where the bulk of the energy and the bulk of the opportunity to reduce consumption exists. So what are some of the drivers? What are the pain points we feel here? I think that one of the primary ones are high energy costs, and they're going higher. In the residential user in Austin Energy service territory, they're facing about a 13% rate hike. In the commercial space, that rate will increase anywhere from 1 to 22%, depending on the demand patterns of the building. And so they're high. The ratepayer is faced with high maintenance costs of running around trying to control this energy. They're also faced with HVAC problems. HVAC, by definition, is an imperfect thing. It's over time. It has degradations. We need to have visibility into those before the massive failure occurs, before the customers are hot in the lobby, or before your tenants are wanting to leave because your air conditioning keeps breaking. So these are some of the pain points that are felt by the ratepayer in the commercial building space. And so they understand, the commercial building operator understands the need for some system that can provide an integrated solution for managing their energy. So I want to get into a little bit of detail on the technology. I don't want to go too deep, but I want to give you some understanding of what an energy management system consists of. Essentially, this is a retrofit solution that comes in and starts to control the energy loads inside a building. What we're doing is bringing things like smart programmable thermostats wirelessly networked into gateway devices. Gateway devices can control the thermostats, they can control the lighting, they can control other large loads in the building, and those gateway devices then network into cloud-based computing platforms that give control over the devices. And then that control is done through applications like your smartphones and pads, through web pages. And so the owner-operator then is able to manage their energy more efficiently. The interfaces into the smart grid are along the lines of everything from understanding the meter, understanding what data or what consumption looks like on the utility side, as well as giving interfaces for new programs that the utility will offer, like demand response programs, where they can provide incentives for the building to reduce power during peak periods. And utilities will be migrating to new pricing plans like time of use pricing. We already have demand charges here in Austin, have one of the highest demand charges in the country for commercial buildings. And we will have price signals coming down from utilities where when the utility has peak power needs and the costs of providing that power are the highest, signals will go out to systems to indicate your price on that energy has increased or decreased, and these intelligent systems will be able to adjust things according to parameters you've set. You will set parameters that say, oh, I've got discretionary loads. When the price swings above some particular set value, I need to move the consumption to a period where there's a lower price point. And so these are leverage points for giving a building owner the capability to reduce their costs and using this smart grid of the future to provide value for the owner of the building, or the person paying the bill, essentially. Another key component here is outage detection and prevention. So when an air conditioning system, say, is starting to degrade, early warning into that degradation is extremely important. You'll see it in your house. You'll know that, oh, I'm hot on this side of the house and the air conditioning system doesn't seem to be catching up. And maybe you'll even hear the unit is running all the time. But you have very little visibility into that. A building owner has even less. They may have hundreds of thermostats. They simply cannot have 100 people walking around checking the vents and seeing if the cool air is coming out, or seeing that the unit is running all the time. The units are on the rooftop. They can't hear them. So what we need to do is provide an early warning where when systems are starting to lose their efficiency, when they're starting to degrade, we can keep tabs on that, alert that, and the energy savings in there is immense. You know, if you imagine what it looks like for a building owner to have hundreds of units running all the time, unable to keep up, and having no visibility into that until they totally break and their customers come to them and say, you know, I'm hot in the lobby. That's really the opportunity. You've got an enormous ability to reduce the cost of those unplanned outages. I have a real-world example for you. We did a building in Dallas that had 162 thermostats, and the first day we turned the system on, we found 42 units that were either degraded or completely failed. We had the HVAC company come in, repair those units, and the energy savings that resulted on a month-to-month basis was in the many thousands of dollars per month for that building owner. And so their return for that investment of putting that system in went from what they originally projected of about 2 years inside about a year. Inside 6 to 8 months, they were going to return on that investment and then be in the positive from there on. What does it do for you as a company? Companies with sustainable building practices and sustainable green buildings and other forms of sustainable activities outperform their peers. There's a sustainability index. They're on average 15% more valuable than their peer companies that don't have sustainable practices. So from a business standpoint, it's more valuable. The buildings as well become more valuable as the energy management system is implemented. Occupancy rates increase. They're able to provide features to their tenants. Tenants can control their own energy, and within parameters they can have a level of control that other buildings don't have. So the renters want to move into buildings that are lower operating cost and have better features. So that provides a better value for the building itself. Green buildings also provide a value in additional rent revenue, for example. It's estimated that 3 to 6% is the average increase when an energy management system is placed into a building, and that the tenants they'll pay a premium to have that lower operating cost and those additional features. There's also a benefit in terms of the marketing and the press. Lead points are available. The ability to market your building as a green building, market your company as a sustainable company becomes a more and more important part of your marketing effort as time goes on. These are graphs that show the benefit to a building owner on implementing green technologies. The average savings is around a 30% reduction in energy consumption. That puts their return on investment for the investment they make in that technology inside 2 years. And if you're a building owner and you want to look at the short list of things that will return on investment inside 1 to 2 years, it's a pretty short list. And so this is really low-hanging fruit. And then the way it affects your environment is a huge important factor here. In that building I mentioned in Dallas, by virtue of the energy savings in that building and how energy is generated in the state of Texas, and in particular in their Dallas provider, electric utility, they will save over 1 million pounds of CO2 each and every year by implementing this system. Basically, I want to just stress the triple bottom line here. people, profit, planets. What we're trying to do is improve the ability for people to manage and the ease of maintenance, profits, reduce cost, increase value, and of course the planet, reduce emissions, reduce our energy issues in this country around availability and time. Rolling blackouts can become a thing of the past. Those are some of the objectives we're seeking here. Thank you all.